Welcome to solverfy.
6.67. So a geologist who's looking for oil has found that the gravity in some spot is 2 parts in 10 to the 7th smaller than average. And so given some assumptions about the density of rocks and the density of the oil and the deposit being 2,000 meters directly below where the geologist is, we want to figure out the mass of the oil deposit, and we're going to be assuming that the deposit is spherical. So this is the Earth, and here's our spherical oil deposit. This is our 2,000 meters. This is going to be the radius of the Earth minus that. And then, of course, the radius of this bigger circle, if we pretend it's a circle, is the radius of the Earth. And I don't believe this is how you actually can estimate the size of an oil deposit. So this is useful educationally, but if you're trying to interview with an oil company to work as an exploratory geologist for them, you probably want to read up on how they actually do this. So our effective G is going to be the G of the entire Earth. So what we're going to do here is use the fact that we're outside of all of these spherical masses, and so we can treat them as just point masses. And what we're going to do is find the gravity due to the Earth with a hole in it that's the size of the oil deposit, and then add in onto that the gravity from the oil deposit. So it's sort of a superposition thing. So it's going to be the gravity from the actual Earth minus the gravity from the missing part, which we can call M for missing, I guess, plus the gravity from the oil. So this is going to be the Earth's gravity minus G over R squared of the plus minus the mass that's missing from the Earth plus the mass of the oil. Or we could have the minus sign here and have the minus sign out here. It doesn't really matter. So then what we'll call delta G is the actual gravity of the Earth minus, or the gravity of the full Earth minus what's been observed here. And so this is going to be equal to our G over R squared. And then we can take out the volume time. We're going to express these as the volume times the density. And in both cases, the volume is the same because it's the same spherical hole in the Earth we're thinking of. And so we have the density of the part that's missing minus the density of the oil. And so this needs to be equal to 2 parts in 10 to the 7th of G, which we're calling GE here, so the volume of the oil is 2 over 10 to the 7th times actual G is r squared over big G times the difference in the masses to the -1 power and so this is 5 times 10 to the 7th cubic meters, which corresponds to a radius of the oil deposit of 200 meters. Just take the 4/3 pi r cubed and solve it for r. And the mass of the oil, just multiply this by its density, is 4 times 10 to the 10th kilograms.